Here we're asked to find a couple of derivatives involving inverse tangent functions. The first one says y equals arctan of the quantity x squared minus 1. Okay, so let's bring up the derivative of arctan to remind us what that is. Recall that the derivative of arctan x is 1 over the quantity 1 plus x squared. So note that the chain rule tells us that the derivative of arctan u would be 1 over the quantity 1 plus u squared times u prime. Times u prime. So just keep that in mind, that we'll almost always be using this derivative in conjunction with the chain rule. Okay, so taking this derivative gives us y prime equals 1 over 1 plus whatever is inside those parentheses squared. Well, okay, in this case it is x squared minus 1 times the derivative of the inside. So what is this thing? Prime. X squared minus 1 prime is 2x. Okay, so now let's just clean this up a little bit. 2x over, we can expand this bottom part out. 1 plus x squared minus 2x plus 1, giving us a final answer of, how about 2x over x squared minus 2x plus 2. Now, every once in a while, I see someone try to cancel like this. Oh, a 2 can cancel the 2. You cannot do that. The general rule of thumb says you can't cancel when there's pluses and minuses outside of sets of parentheses. So here we have plus or minus. That's not safely nestled inside of parentheses, so we cannot cancel across the numerator and the denominator like that. Alright, there's our final answer of our simplified derivative there. Let's try part B. We have g of z equals arctan of the quantity 1 over z. So why don't you try this one, pause the video, see if you can work out this derivative, make sure you simplify it, and then we'll compare notes on that. Okay, so the derivative here is g prime of z equals, okay, well, 1 over 1 plus, instead of x squared, we have 1 over z quantity squared times negative 1 over z squared. Now, where did I get that? Well, you can treat this as z to the negative 1. So when you go take the derivative of it, the negative 1 comes down, you subtract 1, giving us negative z to the negative 2, which I've written here in a slightly different form. Okay, well, there's a lot going on here, so let's see if we can clean this up a little bit. We're done with the calculus, but the algebra is always non-trivial. Let's see. 1 over, I'm going to bring this negative to the front. 1 over 1 plus 1 over z squared times 1 over z squared. So I'm just going to multiply the tops together and the bottoms together. What that gives us is, interestingly, negative 1 over z squared plus 1. Right, because this z in the bottom distributed through to both of these, and in that second term, the z squareds cancel out. So that's our final answer.